All right. What's up, fam? I just had a 1 hour and 15-minute discussion with my pops about science. We're Serbian, so we talk about Tesla. Everyone should talk about Tesla. Why is that? Because everything we've invented, Tesla worked in the 1900. He was born 1850, did his work before 1900 and in the early 1900s. And everything we do in engineering, from electromagnetism, AC current, AC voltage, AC power, three-phase, AC motors, AC induction, and then frequency waves, radio waves, communications, remote control, power generators in the Niagara Falls, residential homes using AC current, transformers, power lines, distributed generation, all that stuff in terms of electrical engineering, that's under the realm of electromagnetism, was created by Tesla. And the only thing we've really researched since then, almost 120 years, is like semiconductors, superconductors, nanoconductors, and metamaterials. Some metamaterials now are like electromagnetism because they deal with fields and waves of light and cloaking devices and stuff like that, invisibility. So some metamaterials are electromagnetism, but all of this other research, which is semiconductors and materials and nanoconductors, superconductors, whatever, are like transistors. And transistors are little switches that operate mathematical computations in circuits, in small circuits. So basically everything we've done for the past 100 years has been on computers. Now, what is a computer? It's a processor, which is a clock cycle, gigahertz, 4 gigahertz. Memory, which is magnetic memory, RAM and ROM, and cache, which is type of RAM and ROM, which is magnetic memory, and it's like, that's where all the registers are, where numbers are stored, where 1010 bytes and bits. How big is it? 4 bits, 8 bits, 62 bit, 64 bit. Now all these ones and zeros turns into a real number, 0 to 9, A to Z, and data. So you have your data and your registers, you have your CPU, which is your clock cycle, and then you have your operators, which are the logic gates, ones and zeros, combining two pieces of memory into another piece of data. So transforming data and doing calculations, all that is done with the registers into another register with the transistors, which form the gates. So, and you got trillions and billions of these transistors. So computers now are faster and bigger in size and memory, right? And of course, you got the inputs, your mouse, your keyboard, your screen. Now, and your speakers. All of that, up amplifiers and whatever, feedback loops and transistors and current mirrors and whatever, are done with transistors, which is where the research is, the conductors, the semiconductors, the polynanomers, and whatever. So everything we've done in research for the past 100 years has been in computers. And everything else, AC induction, Faraday's law, transformers, generators, turbines, motors, communication, antennas, cellular, Wi-Fi, Bluetooth, radio waves, antenna waves, bandwidth, frequency, power amplifiers, signal amplification, communication systems, all of that hardcore engineering, which is not computer or software, have been doing that since Tesla's time, 1900. 1900. And then we got the chemical side, which is petroleum engineering, nuclear engineering, and just chemical mixtures, even used in medicine, which chemical compounds, because your body, your biology is chemicals. Now, they're organic chemicals, which means hydrogen, oxygen, nitrogen, and carbon. Those four are organic. And proteins are amino acids, which are like hydrogen, oxygen, carbon, chain of those. And then the endings are amino acids, and there's 20 of them, and they include nitrogen. So how do we structure these proteins? What do they do in the body? They are signals, receptors on the membranes, communication channels, activation channels for transmitting ions and chemicals and nutrients into the cell, commands for the cell to break down, to live, to die, to reproduce, neurons, and all these parts of the cell which function and live are dictated by proteins. So my theory was to get natural healing by fixing all these proton irregularities, whether it's through DNA, whether it's through manufacture technology like CRISPR, which is called the computer manufacturing technology for proteins. So using CRISPR to change the protein, either removing some proteins or having them confuse each other. So having offset reactions which mess up the bad proteins and help the good proteins. And you got balances. So that's my theory on molecular biology, is the protein synthesis, not just chemotherapy and radiation and chemicals and vaccines and pills. Vaccines and pills, but that help these protein regulations. Natural nutrients and rebuilding and repairing and preventing diseases and stuff like that, based on, because when a protein eats and replicates as cancer, the protein signal to die and to eat healthy is messed up. So you got to put that back in and remove the negative proteins that say to eat, to not die and whatever, and replicate. So my area of research has always been the protein level. So that's biology, that's electrical engineering, and that's computer engineering. And some chemicals. Why do I say chemicals? Because for electricity, we have generation. Now we're also doing some research into solar generation and wind generation and hydroelectric dams, whatever alternative energy sources, mainly solar. But we got traditional energy generation, which is Faraday's law, which is how much the magnetic flux changes through an inductor, through a coil. The magnetic flux changes, and that produces DC, that produces a generation. So you got a turbine spinning magnets or spinning the coil, and that changes how much magnetic flux, how many magnetic field lines are going through the coil and creating this generation. So that's a law of induction, and that's how we create transformers, basically transform the current and the voltage. High current, low voltage, high voltage, low current. Voltage is like the top line, and current is the physical energy. So if you have a lot of current, you die. If you have low current, you live. But voltage is how much current can be created. They're related. Voltage, current, and resistance. So if you have your resistance, which is your human body, and you touch high voltage, that's going to create a lot of fucking current, which will then kill you. But the voltage by itself is not dangerous, which is why Tesla sat in like a chamber creating like hundreds of thousands of volts, but it was low current, so he could like sit and not die. And there's pictures of him sitting in his megavolts and low current and all this sparks and whatever, and he's just chilling reading a book. That's Tesla. And communication is electromagnetic waves, radiation. It's like light, but different frequencies. So different frequencies of light, frequency is how fast the wave oscillates. Wavelength small, wavelengths big. 2-meter wavelength is a radio wave. 1 centimeter wavelength is an X-ray. Like 10 centimeters wavelength is visible light. So it's all the same electromagnetic wave, but the frequency changes how much energy it has and changes the wavelength. And that's how you get a radio wave, an X-ray, a gamma ray, a microwave, an infrared wave, an ultraviolet wave. So you have light, ultraviolet, infrared, microwave, gamma ray, and radio waves are here as well. So that's communication systems, and that starts on the chip, power amplifier. The current turns into a wave in the atmosphere based on the end of the circuit. The circuit has a half wavelength dipole, and that converts the AC current. Now AC current on a conductor, on a wire, on a chip, AC current shoots out a half wavelength dipole into radiation, into a satellite, antenna, whatever. Bounces through stuff, bounces around stuff, all sorts of stuff. That's part of electrical engineering. And then you have that's it, transformers, communications, and the computer. That's all of electrical engineering. What else is there? That's it. That's all there is. Transistors, semiconductors. Then you got your stuff like control systems, which is feedback and the mathematics behind controlling acceleration, voltage, current, tracking an input to not explode and not have positive feedback, which goes into an explosion or whatever, right? And then you have your chemicals, which is your chemical reactions. Now, one of the areas of research I was interested in was storing electrical energy, because we can produce it, we can communicate it, we can transmit it through power lines and distributed generations and generation station and power lines and transformers, but we can't store it. We got some batteries. You convert electrical energy into mechanical energy. You convert mechanical energy, a turbine, into a generator, electrical energy. You have electric motors. You have nuclear energy, petroleum and nuclear. But you don't have a way to store electrical energy other than batteries, which are very small. So I said, let's store electrical energy into chemical energy, Now, the thing is, I learned that this chemical energy is reactive. So it's like a bomb. It's a fucking bomb, but it's a bomb anyways. You can create it without electricity and create a bomb anyways. The plus side is it'll be clean. It'll be renewable. So you have hydrogen electrolysis, which is creating hydrogen fuel from electrical energy. And how you put that, it's like gasoline. Gasoline can explode. Hydrogen fuel can explode. The main difference is hydrogen is clean. So no carbon dioxide, no pollution. It's clean energy. So you can put that in a car, in a vehicle, in machinery. So I said convert electrical energy into chemical energy, hydrogen. And that's a way to store energy, because there's no way to do it electrically other than batteries. And we talked about the human body, the chemicals, the nitrogen, oxygen, hydrogen, carbon, which make those molecules. Now you have your respiratory system, your digestive system, your sexual system, your neurological system, your nervous system, your circulation, and you got homeostasis, and you got your organs, your liver, your heart, your pancreas, your kidneys, your lungs, you got your muscles, you got your neurons, you got your neurons need to have correct levels of neurotransmitters and to not die and function properly, which is your nervous system, your motors and shit like that, and your regulation, your breathing, your digestive, your heart rate, your muscles, and your brain, which is this nervous system and this. So it's the extra nervous system and the peripheral nervous system. So you got the brain and the body, and it's all neurons. So neurons need to heal, not die, not be diseased, for your body to work and your brain to work. That's the neural system. And then you got the respiratory illness, which are viruses. Why can't we combat viruses? It's because they're all different. There's billions of viruses and they're all different, but we got to find something in common. They don't have a life. They're not a living thing. They attach to a host and then they put their DNA inside the host. We can't target the DNA because it's always different. It's billions of different viruses, billions of different DNA. But the DNA is held within a capsule, and if that capsule dies, the DNA dies. So we got to find out how to attack this capsule, which is a protein, to kill viruses. Now the problem with targeting cancer and viruses with proteins is if you do it incorrectly, you'll create problems. You create cancer and viruses and whatever. So you got to be very specialized in correct application of treatment when it comes to dealing with microproteins at the cellular level. But that's how we can target viruses and cancer and the neurological system naturally. Pills and vaccines and food and that stuff. And exercise and health and that stuff. So we did biology, chemicals, electrical engineering, and now all we're left with is physics, astrophysics, okay, and quantum mechanics and astrophysics. So the theory of everything is you got protons, you got electrons, you got neutrons. That's matter. And antimatter is the opposite of matter. Protons are negative, electrons are positive. And the universe is 5% matter, 1% antimatter. And when matter combines with antimatter, you get nuclear explosion. But they never meet because antimatter is somewhere far away and matter is far away. 5% and 1%. And matter and antimatter are made up of quarks. So like you have an up quark and you have a down quark and you have a charm quark. And it's like a proton is two up quarks and a down quark. So it's basically what makes up a proton, an electron, and a neutron. How many quarks, how many up, down, and charm quarks make up an electron and a neutron. And we believe there are different quarks and charm quarks which make up the antimatter. So that's matter and antimatter, electrons, neutrons, protons. Now, what are the bosons? The bosons are force-carrying particles. So you got four forces. You got the nuclear force, you got the weak nuclear force, so you got like protons and neutrons. Then you got like protons and electrons, which are farther apart. And then you got the electromagnetic force, which is weaker, which is charges, positive, negative charge, electric force. You got the gravitational force. So those are the four: nucleus, electric, and gravity. Now, what the bosons are force-carrying particles, meaning this is how no teleportation happens. You have a charge here and a charge here. They're attracted or repelled. How are they attracted or repelled? There is literally a fucking boson, which is a particle which has a mass and a spin and a charge, which travels from this bigger particle, the electron or the proton, to the other particle and pushes it or attracts it. So those are force-carrying particles which travel at the speed of light. That's why if you have things that are far apart, they won't get attracted or repelled until the speed of light reaches them, and then they will attract and repel. And how do we know these bosons and these subatomic particles exist? Is when we have particle accelerators and we combine them at high speeds, and for nanoseconds of lifetime, we see on a computer they exist. They have this spin, this charge, this mass, and they travel like this, and we see these bosons and particles that exist. Now, what was the Higgs boson? The Higgs boson was a big discovery. Why was it big? Because it's the boson that connects matter, that connects how matter exists between matter. Because E equals mc squared. Energy can be converted to mass, and mass can be converted to energy. So how do you convert energy into mass into energy? You have the Higgs boson, and that's how matter is created. And they actually discovered the Higgs boson in a particle accelerator. But all these bosons and subatomic particles were the 1800s and 1900s scientists. Einstein, Bohr, Copenhagen, all these guys that lived in the 1900s. Now, there is a photo with all the scientists, the popular photo with Einstein and his 30 guys, scientists, at a Nobel dissertation symposium. And that photo was taken in Serbia, in front of the Serbian School of Engineering or something like that. And that's probably a devotion to Tesla. Yeah, I don't know if Tesla was there, but they lived at the same time. So Einstein was born after Tesla. So this photo was taken in the early 1900s when cameras existed, black and white, in Serbia, in front of the Serbian School of Engineering or something like that. That's where that famous photo was taken. So they got these subatomic particles and these bosons, and all of this was theorized in the 1900s and then proven 80 years later with particle accelerators. So the universe is 5% matter, 1% antimatter. What's the rest? The rest is something called dark matter. It's 27% dark matter. What's dark matter? It's basically like matter, but we can't see it. So it's in the galaxies, and we know it exists because when we observe these galaxies, the only way these galaxies can exist is if they had extra gravity in them, and that gravity must come from matter. But it doesn't interact with light, so we can't see it. So it's like matter, but it's dark. And we can't see it, but it's adding some gravity, which is holding these galaxies together and giving them mass. And now we believe there are particles and forces that make up dark matter, like their own quarks and leptons and bosons and whatever. Or maybe the same bosons. Now, so that's 5%, 1%, and 27%. And the remaining 60% of the universe to 70% is dark energy. It's energy. Dark energy. It's not dark matter. It's dark energy. And it is the opposite of gravity. So, gravity is pulling things together. Now we believe we haven't discovered, but we believe there is a gravity boson, a gravitron, which transfers between two mass the force of gravity. And dark energy pulls everything apart. Now, because there's more dark energy than gravity, the universe is accelerating in expansion. It's expanding faster and faster. And the theory is everything will be ripped apart, or it'll reach a point and everything will collapse back in, or it will find some kind of balance. Those are the three possibilities. So that's everything. Now, the last thing is quantum mechanics. Quantum mechanics are these particles, these electrons, bosons. Now, the thing is, when you observe mainly electrons, when you observe an electron, it's traveling like a particle and a wave, So electromagnetic radiation, all these electromagnetic waves, which we said light, infrared, microwave, UV, are an electric field and a magnetic field like this, electric, magnetic, and it can rotate, but it's always 90 degrees. So electric, magnetic. Now, some say, well, it is. An electron is like a wave, but when we measure it, it becomes a particle. So because we can never know whether it's a wave or a particle until we measure it, there's always combinations. Like it can be here and it can be here at the same time. And Schrodinger's cat says it's both at the same time until we measure it. So it's like a box. The cat is alive and dead until we open it and we measure it and we observe it. So when we observe the electron, we find out, aha, it's here. But until we observe it, we don't know if it's here or here. It's two places at the same time. Now, alternate universes and alternate realities, which is the Copenhagen stuff, which was also hypothesized when we discovered this quantum physics, was, okay, maybe the electron, we find it to be here, but it may have been here. So we find it here, but in an alternate universe, it was here. And because this quantum particles exist everywhere in our bodies, in our matter, in our antimatter, in our dark matter, the entire universe is a system of alternate realities. So when the electron happens here and here at the same time, based on which universe it goes into. I don't believe that, but that's the alternate reality explanation. And the theory which supports these alternate realities is string theory. Maybe a string that vibrates with one wavelength is a boson. If it vibrates with two wavelengths, it's a proton. If it vibrates with three wavelengths, it's an electron. Or it's energy. So everything is a string that vibrates, everything. And that's how you can go into higher dimensions based on how many strings vibrations there are. Problem with string theory is there's no way to prove it. It's got 0% proof. Just a theory. So I don't believe there are more dimensions than 4. 1D, 2D, 3D, and time. I don't believe there are more dimensions than 4 because we can't observe it. We haven't observed it. And the theories arguing that there are more dimensions than 4, some say there are only 5, or there's only 6, or there's only 7, and some say there are dozens. But most of them say like there's only 7. I don't believe it at all because the theories supporting alternate dimensions and higher dimensions are very small, very crappy. They're very crappy. There's no concrete quality, evidence-backed theories saying we may live in, there may be higher dimensions that we don't see. So I believe there's time. And now, if we could travel faster than the speed of light, we would be able to go back in time. Problem with the speed of light is that's what the cap limit for all of science. Quantum physics travels at the speed of light. Photons, which are the bosons that carry light and electromagnetic waves, travel at the speed of light. Electromagnetic radiation, which are these photons and electrons, photons, travels at the speed of light. Electricity travels at the speed of light. Everything is capped. Quantum physics science is capped at the speed of light. And if something could travel faster than the speed of light, we'd be able to go back in time. So I don't believe anything can travel faster than the speed of light. I don't believe we can go back in time. Now, we can manipulate time. We can make time slow down. That's Einstein's theory of relativity, based on speeds and velocities. High speeds, things slow down relative to other things. So if you live on a rocket ship, in 20 years, everyone on Earth will have aged 80 years. So you can slow down your biological aging if you travel in a rocket ship. That's proven. That's physics. So we can manipulate time. It's called time dilation. Just like that, we can manipulate distances, which is called distance dilation. So we can change distances and we can alter time, but we can't go back in time. There's no alternate universes. Probably no strings either. And the last, this one's a little bit iffy. And that is the theory of teleportation. What is the theory of teleportation? It's the Copenhagen trials. Because in order for this particle to be here, when we measured it, it started here. And in the alternate universe, it's here. So it can be two places at the same time. How the fuck does it know when we measure it to be here instead of here? Because sometimes it's here, sometimes it's here. Did it teleport? That's called locality versus non-locality. At some point in its lifetime, it started off here and ended up here. Now, either it got the information to be here or here at this moment in time, which means the information is teleporting. It's teleporting between here and here. It's saying, go here, go here. That's non-locality. That's teleportation. Or the quantum particle, back in time, got the information when it was here. Whether at this point in time, it would be here. That's locality. So locality says, I give you the information when you're still here. You end up here. And now you use that information, which I gave you, which was not teleporting. And you picked whether you're here or here. So there was big arguments with the Copenhagen stuff, whether locality or non-locality. And that makes a big difference in science, whether information can teleport. And I believe it cannot teleport. I believe there's locality. So I believe there's no teleportation, no going back in time, no traveling faster than the speed of light, no alternate universes. That's what I believe. And the last thing I will say is science is God. Science is God. Religion and science are not separate. People think religion and science are not separate, but I have an IQ of 136. I'm in the top 3% of the population. Gifted. I took IQ paid IQ test. 1 hour. Or half an hour, 40 minutes, whatever. The person with the highest IQ on earth, who knows about all this physics shit, also believes there is God. The only way this universe can make sense is if God designed it. The dark energy, the Big Bang created how much matter was in the universe, how much antimatter was in the universe, how much dark energy was in the universe, how much dark matter was in the universe. So God created this Big Bang and the universe and the timeline and the sustainability of life. DNA, our organic materials, hydrogen, oxygen, carbon, nitrogen, our bodies, our consciousness, and our ability to understand life. The people of Egypt, 5,000 years ago, religion. I believe God played a role in all of that. And it's our job to keep understanding science and the Big Bang Theory and the matter and the dark matter and the dark energy and the DNA and the medicine and the surgery and the vaccine and the pills and the cures and the understanding how our body and the DNAs work and the science works and the physics and the chemistry and the molecules and the atoms and the matter and the bosons. I believe all that was created by God because it all fucking makes sense. And the only way it can fucking make sense and live in a perfect balance is if someone created it. God had to have control over it. And the flow of time. Now, the one thing I believe God does not have control over is man's souls. Man's souls. Because there is a devil. And that's why you can have injustice and wars and greed and corruption and crimes and impurity and corruption. The devil corrupts man's souls and God brings them to light. So God created the universe and the DNA and everything, but there is the devil and angels which compete for the soul and body of man. And our inner soul, our inner life of what we believe, how we act. Right? And that's everything. That's the true theory of everything. Biology and medicine, brain, central nervous system, viruses, cancer, electrical engineering, electromagnetic waves, AC currents, chemicals, physics, theory of everything, computers, software. Software is just the writing, which basically is converted into these transistors and this registers, RAM, magnetic memory, and the CPU, the clock. So software is just the language which gets converted into hardware. And that's all. That's all the research I've been doing. Oh, the environment. So the environment is another one we got to take care of. That's the planet. That's the fucking goddamn planet. The environment. And that's all of science, and that truly is everything. And then you got mathematics. So mathematics, which is algebra, trigonometry, and calculus. And those explain forces and physics and chemistry. It's called mathematics. Now, we are looking for more breakthroughs. We're trying to solve this theory of everything, all these particles and dark energy, dark matter, and universes, whatever. We're trying to solve medicine, DNA, and cancer, and neurological diseases, and viruses. We're trying to solve electrical engineering in terms of energy, communication, computers, transmission, storage. We're trying to solve chemistry to discover all the elements and discover new, because some non-organic chemistry like gold and aluminum and zinc and copper and magnesium goes into our body and does beneficial things until it becomes toxic if you have too much. So we got to discover more chemical compounds which can heal our bodies and create compounds, materials, steel, conductors, concrete materials, petroleum, nuclear. So we got chemical and nuclear. Physics, theory of everything. Medicine, biology, mathematics, and religion, the creator. And that's everything. 40 minutes, that's all my research. Quantum electronics, speed of light, particles, Copenhagen test, Schrodinger's cat, and transistors, vaccines, pills, gravity, gravitrons, bosons, theory of relativity. And then we have AI, artificial intelligence, which is the form of software. So artificial intelligence, what's going to happen with there? It's got to follow the laws of physics. It's got to follow the laws of God. It's got to follow the laws of the universe. Nothing magic, just artificial intelligence. Now, I didn't cover my films, my music, my video games and graphics and all of that stuff. Design. I didn't cover any design stuff. This video was just for the science and the creator and the universe. And I hope that covers everything. Got my science folder, did everything. I had this exact same conversation with my father 40 minutes ago for an hour and a half, and now my voice is dead. But I hope we learned something. So, Kikyo12, stay real. Learn something from this video, share it with a friend, tell somebody, and stay classy.